Welcome back to my series on solving other types of equations. In this video, we're going to take a look at equations that involve rational exponents, and I'll get into what exactly those are and what they look like and how we can solve them. So let's dive right in. Rational exponents are just like any other exponents. We have squared or cubed. A rational exponent just means that it's part of the rational numbers, and the rational numbers are numbers that can be written in the form of p over q, where q is not equal to 0, so it's basically just a fancy way of saying a fraction. So rational equations with rational exponents are going to be equations where our variables are raised to a fraction or have fractional exponents in them. So as we can see here, this is our equations in the form x to the m over n is equal to k. And we want to remember that x to the m over n is really just x to the m, and that's to the nth root. So if we had something like x to the 2/3, that's the same thing as x squared and the cubed root of that. So how do we solve these? Well, we have to be very careful because we have to remember that just like when we have the square root, we have to think about the positive or negative square root when we solve for those, because when we multiply negative times negative, it'll give us a positive, and the same thing, multiply positive times positive, it'll also give us a positive. So we have to look at two different cases here. If our m is even, so we have something like x to the m over n equals k. If our m is even, which would be like a squared or to the 4th or something like that, what we're going to do is we're going to raise it to the reciprocal. So we have x to the m over n. We're going to raise both sides to the n over m, the reciprocal of m over n. And we have to remember that we have to take the positive and negative, because that is just like squared. When we take a square root, we have to think about the positive and negative. And if you think about this, if this was just x squared, then we would want to raise it to the 1/2, which is taking the square root. And when we take the square root, we have to take the plus or minus square root on the other side. K to the 1/2 we'd have over here. So we're just doing the exact same thing. And also in the previous video, when we looked at solving radical equations and we squared them, we were doing the same thing. We had the square root of x and we squared it. Well, that's the same as x to the 1/2 squared raised to the 2nd power. And when we multiply those, we get 1/2 times 2, which is really 2 over 1. So we can see these are actually the reciprocals. So we're really doing the same thing. We're just going to be using things more than 1/2. We're going to be looking at the cubes and to the 2/3 and things like that. But it's really just the same thing. So if m is even, we need to think of positive and negative. If m is odd, we don't have to worry about that, because say cubed, if we have a negative cubed, it'll be a negative times a negative times a negative. The two negatives will make a positive, and the positive times the negative will again make a negative. So we will end up with the same sign that we started with. So when we deal with odd, we just need to raise it to the reciprocal, both sides to the reciprocal, and we don't have to worry about putting the plus or minus in front. So let's go ahead and take a look at some examples to clarify. So we're going to start with a pretty straightforward one. If we have x to the 3/2 equals 27. So what do we do? So first we'll look at m. Well, m, that's our numerator here. That's 3. So since it's odd, we don't have to worry about the plus or minus. So we can go ahead and solve without worrying about that. So we're going to raise this to the reciprocal, and remembering that for the reciprocal, we just switch the numerator and denominator, so that's going to be to the 2/3, and we need to do that to both sides. Now, when we have exponents and exponents raised to exponents, we multiply them, so the 3's will cancel out and the 2's will cancel out, and on the left side, we'll just get x. Now, we can think of this as 27 to the 1/3 squared. Well, 27 to the 1/3 is 3. 3 times 3 times 3 is 27. So that's 3 squared, which is 9. And so we get x equals 9 as our solution. And as always, it's good to check. We look at what is 9 to the 3/2. Well, that's the same thing as the square root of 9 cubed. Square root of 9 is 3, so we have 3 cubed, and 3 times 3 times 3 is 27, which is what we want. So we can see that this is the correct answer. So in this case, our solution set is 9. So let's go ahead and look at some more examples. So here we have 8x to the 5/3 minus 24 equals 0. Well, if we just think about our previous example and wanting to kind of make it look like that so that we can solve, the first thing we want to do is add 24 to both sides. So if we do that, we get 8x to the 5/3 is equal to 24. Well, now since the 5/3 is just applying to the x, it's not applying to the whole 8x, we don't have 8x in parentheses, we can divide both sides by 8 as well. So then we get x to the 5/3 is equal to 3. So what is our m in this case? Well, our m is equal to 5. Again, that's odd, and since it's odd, we don't have to worry about the plus or minus, and we can proceed to our next step of raising both sides to the reciprocal, which in this case is 3/5. On the left side, our exponents are going to cancel out when we multiply them, and we'll just get x. And on the right side, we have the 5th root of 3 cubed. Well, we know 3 cubed is 27, so we really have 27 to the 1/5, and there's no nice way to solve that. There's nothing you can multiply by itself 5 times and get 27, so we simply have the 5th root of 27, and that's our solution set. And again, I encourage you, go ahead and plug it back into our original equation and check it out and see if it in fact does give us the correct answer, as it should. Let's move on to another example. Here we have the quantity of x plus 5 to the 2/3 equals 4. So in the last one, we were able to move things back and forth over to either sides of the equation because they weren't all being raised to the exponent. In this case, our whole left side is being raised to the 2/3. So we have no ability to move it. To move anything back and forth. So we're going to have to go ahead and start by raising both sides to the reciprocal. Now in this case, our m is equal to 2. So that means we're going to have to deal with a plus or minus. So we're going to raise both sides to the 3/2, remembering to put our plus or minus on this side. So on the left side, the 2/3 and the 3/2 are going to cancel out, and we're going to get x plus 5 equals plus or minus 4 to the 3/2. Well, remember, this is like the square root of 4 cubed. Well, the square root of 4 is 2, and 2 cubed is 8. So that's giving us x plus 5 equals plus or minus 8. Now here we just continue to solve as we would any other equation, and we have -5 plus or minus 8. So this is going to give us two solutions. We're going to have 8 minus 5, which is 3, and -5 minus 8, which is going to give us -13. So our solution set in this case is -13 and 3. And again, we can check it. We can look at it real quick, actually, this one to check it. If we put in 3 for x, 3 plus 5 is 8. So we have 8 to the 2/3 equals 4. Well, we know that 8 to the 1/3, or the cubed root of 8, is 2. And 2 squared is 4. So we have 4 equals 4, and we see that that is the correct answer. If we put in -13, well, we have -13 plus 5. And that's going to give us negative 8. So we'll have negative 8 to the 2/3. And we want to know, does that equal 4? Well, if we think about just taking negative 8 squared, that'll give us 64, and we'll have the cubed root of 64. And that, of course, is equal to 4. So we can see that both of our solutions are valid for the given equation and are in fact solutions. Moving on to our final example, we have the quantity x squared minus 3x plus 3 to the 3/2 minus 1 equals 0. Now again, we've got to just like we did when we did the radicals, we want to have the radical on one side by itself so that when we squared it, it would cancel out. Same thing here. When we raise both sides to the reciprocal, we need the reciprocal to cancel out, which means we have to have that by itself on one side. So we're going to move the 1 over to the right side by adding 1 to each side. Now, as we did previously, we see that m is 3. It's odd. We don't have to worry about plus or minus. Sides to the 2/3, the reciprocal. Now the cubed root of 1 is 1, and 1 squared is 1, so we'll get 1 on the right hand side. The 3/2 and the 2/3 will cancel out, and we'll get x squared minus 3x plus 3 is equal to 1. Now we're going to go ahead and subtract that 1 back, and we'll get x squared minus 3x plus 2 is equal to 0. Now we can factor. If you watched my previous videos on solving quadratic equations and the rule of signs, we know that they're going to be both negative. And since 2 is prime, all we can have is 1 times 2. And we can see that negative 2x minus 1x will give us negative 3x. So this is correct. And by the zero product property, we set both equal to 0, and we get x is equal to 1 and x is equal to 2. Again, you can go ahead and plug those back in to ensure that our solution set 1, 2 is correct and that both are valid answers. That concludes this video on solving other types of equations, those with rational exponents. Thank you so much for watching. Please make sure to tune in to the next video in our series, in which we will be looking at equations that are in the quadratic form, a little bit different. We'll be using substitution to solve. So please make sure to check that out, and thanks again for watching.